Okay, good morning, everyone. Good morning. Morning, Prashant. Good morning, Shnu. Okay, so I'll start with whatever we have left in last class. Okay. So Prashant, So last class में हम ये देख रहे थे कि why there is the difference in path difference. Okay, for dark fringe and bright fringe in case of diffraction, right? है ना? ये doubt था. Okay, so first we will try to understand why that difference. Okay, now just wait, I'll just show you the big diffraction first. ठीक है, so I guess सबको path difference क्या होता है वो समझ में आया था? Yes or no? Right? मतलब path difference क्या होता है इसमें दिक्कत नहीं था ना कि path difference n lambda by a क्यों होता है, कैसे होता है, right? Okay. Now अब मैं बताता हूँ क्यों होता है. Why dark fringe and bright fringe are opposite for diffraction as compared to interference. Now think about it. Suppose think about it. शायद तुम लोग याद है मैंने बताया कि phase difference हो जाता है ना, पाई का phase difference हो आता है. Yes or no? How many of you remember? Tell me. How many of you remember? Right? अब देखो phase difference कैसे होता है. Now suppose this AB is equal to wavelength of the light, right? Suppose this AB is the distance AB is almost equal to lambda. Think about it, right? Okay, and let make a point C over here or O over here, right? O तो यहाँ पे already है, तो मान लो C है ये. ठीक है, तो ये पॉइंट यहाँ पे C है मान लो. Now if AB is equal to lambda, तो सोचो कैसा होगा? Just imagine. ऐसा होगा ना, है कि नहीं? Right? Agree? And this will act as your source. This will act as a source. So can I say that, okay, every point on this AC, right? Every point in AC will have a counterpoint on BC. Think about it, right? और तुमको क्या लगता है AC and BC अगर दो different source की तरह behave कर रहा है तो जो interference pattern बनेगा, जो superposition होके बनेगा वो कैसा होगा? Constructive or destructive? Tell me, because there's a path difference of pi ना. Yes or no for each and every point? Got it? Got it, Prashant? समझ में आ गया? Right? So अगर यही अगर 3π/2 है, suppose यही अगर 3π/2 है, तो कैसा हो जाएगा? ये 3 पार्ट में डिवाइड हो जाएगा, है ना? 3 पार्ट में डिवाइड हो जाएगा. राइट? तो देखो ये और ये कैंसिल कर दिया एक दूसरे को, है ना? ये पार्ट कैंसिल कर दिया और पैटर्न सिर्फ और सिर्फ इसके कारण बचा, सिर्फ इसके कारण, राइट? सो ऑब्वियसली इट विल बी अ ब्राइट फ्रिंज. गॉट इट? आई होप ऑल ऑफ यू अंडरस्टूड दिस, है ना? सो फेज डिफरेंस हो जाता है, इसके कारण ये हुआ. ओके, राइट? ठीक है. सो हम लोगों ने लास्ट क्लास में बेसिकली ये पढ़ा था कि डिफ्रैक्शन होता क्यों है, व्हाई डिफ्रैक्शन इज ऑब्जर्व्ड, राइट? How to find the path difference, which is almost same as Young's double slit experiment. ठीक है? Now we have studied two different type of diffraction, Fraunhofer as well as, tell me, Fresnel. ठीक है? दोनों में difference किसको याद है? I hope all of you remember the difference, that when you talk about Fraunhofer, it is, tell me, it is called as what? No, Fraunhofer is far field diffraction ना, right? Single slit तो रहेगा ही, obviously. Fraunhofer is far field diffraction, right? Light source is very far, okay? But when you talk about Fresnel, this is called as near field diffraction, in which case, right, the screen is nearer to or at a finite distance from both slit, right, as well as the screen? Yes or no? Right? टेबल था ना, ऊपर टेबल था, हम लोगों ने टेबल देखा था. Wait, I'll show you the table. ठीक है, ये बोर्ड से पूछ सकता है अगर कभी आया तो. ठीक है, got it, right? So these 4 points, that we have already discussed in last class. Okay, now अब देखते हैं इस पे क्वेश्चन कैसे पूछा जाएगा. So when you talk about the problems, just think about it, right? Just think about it. Don't you think that the problems that will be asked in this case will almost be same as the problems that is asked in interference, basic problems, right? Find the position of dark fringe, bright fringe, and all those things. Okay, now apart from that, yes, formula based. Okay, apart from that, if we talk about the angular fringe width, because we know that the fringe width in case of diffraction is not same, right? Okay, when you talk about interference, the fringe width is same. Okay, but in case of diffraction, it is not the same. We have observed that the intensity as well as fringe width will vary as it goes away from the central fringe, central bright fringe. Yes or no? Tell me. Yes or no? Right? If you see, so it is like this. Right? Anna? Okay. Now, when we talk about fringe width, there's something on angular fringe width. So we have calculated that theta is equal to what? Tell me, theta is equal to what? N lambda by A for dark fringe, right? And theta is equal to 2n plus 1 lambda by A for bright fringe, where A is the slit width, right? This is what we have studied. Now, just imagine, right, if you are asked to find what is the angular fringe width, tell me, right? Angular width, right? Angular width. So what do you mean by angular width? Tell me. This angle will be your angular width, na? Yes or no? Tell me. This angle will be your angular width, right? So if I see this, right? If I see this, okay. मनोज तुम फॉर्मूला याद कर रहे हो, इसलिए तुम्हारा 2 डिनोमिनेटर में है. टोटल स्लिट का विड्थ मैंने ए लिया है, ठीक है, राइट? अगर तुम यहां से लेकर ये ऐसे लेते, ऐसे, ये ए, तो ये टोटल 2a होता ना. थिंक अबाउट इट. अब समझ में आ रहा है जो तुम लोगों ने पढ़ा था, राइट? उसमें ये डिस्टेंस 2a था, बिकॉज सेंटर से नीचे ए, ऊपर ए, देन इट वाज 2a. बट यहाँ पे क्या है? यहाँ पे हम टोटल ए बोल रहे हैं ना, राइट? इसलिए बोल रहे फॉर्मूला को समझो, ठीक है? ओके, सो या, तो ये क्या होगा? दिस इज योर 2 थीटा. यस और नो? दिस इज योर 2 थीटा. नाउ, so obviously you can find the angular, right? Angular fringe width. Okay, makes sense? Tell me, makes sense? Right? Now what about linear fringe width? Tell me, linear fringe width. Okay, so linear fringe width will be what? Tell me. Theta is equal to L by R. So L is equal to theta into R. So theta into D, because R is D, right? Yes, very good. See, है ना? ठीक है. So this was the concept that I was talking about. Linear fringe width is 2d lambda by a, right, for central maxima. Angular fringe width 2 lambda by a for central maxima. Anyone have any issues? Tell me, anyone have any issues in this? इस पे सिर्फ फॉर्मूला पुटिंग गेटिंग क्वेश्चंस आएंगे, ठीक है? ये तुमको बोर्ड्स में पूछ सकता है, ड्राइव करने के लिए पूछ सकता है, ठीक है? किसी को दिक्कत है इसमें? उदय, दिलीप अभी ज्वाइन किए, प्रशांत समझ में आ गया पूरा? चिन्मयी? Okay, ठीक है, right? Now after this, when we talk about right? One special case, which is basically when lens is very near to the slit, right? हम लोगों ने जब यहाँ पे देखा था, तो lens was a bit far away जब drive किया था, तो है ना? But suppose length is this slit, right? Slit and the lens is very near to each other. Then what will happen? Tell me. Then what will happen? Yes, that's it, right? D की जगह पे F use होगा. Okay, as simple as that. और कुछ नहीं. Focal length will be D. As simple as that, right? Yes, Harsha, very good. Right? Ray optics use हो जाएगा. Okay, but again, the main concept that we have to remember here is D will be equal to F. There will not be any other difference. Okay, right? तो जहां जहां पे हम लोग D use करते हैं वहां पे F use करेंगे. So ये D ना देकर तुमको focal length of the lens दे देगा. ठीक है? Got it? ओके ना एक चीज बताओ, तुम लोग एक चीज बताओ, अगर हम बात करते हैं fringe width की, right? Suppose we talk about the fringe width. Okay, so what will be the fringe width of central maxima? We calculated the fringe width of central maxima, right? This, right? This. Okay, yes or no? Okay, now what is the fringe width, right? Okay, what is the fringe width or linear width? Doesn't matter, you just talk about linear width of second maxima, secondary maxima. Think about it, secondary का क्या हो जाएगा? Tell me. Lambda d by again, right? या तो तुम 2a मतलब पूरा 2a मतलब तुम fringe width बोल रहे हो, ठीक है? और a, तो Prashant, I'm considering that 2a, you are saying that slit width is 2a. Okay, yes. So I can say that, right? The distance between two dark fringes, right? The distance between two dark or two minima is your, right, fringe width of secondary maxima. Yes or no? Which is lambda, yes, lambda d by a. Very good, lambda d by a. Now, if I subtract this minus lambda d by a, sorry, if I compare this and lambda d by a, what can I say? Tell me, what can I say? Central maxima का fringe width will be twice of the secondary maxima का fringe width. Yes or no? Right? जो हम लोगों ने intuitively बोला कि जैसे जैसे center से दूर जाता जाता है वैसे वैसे मेरा fringe width कम होते जाएगा. So can I say that width of secondary maxima is inversely proportional to fringe width, right? Using this formula. Okay, that's we already know, right? That width of maxima or secondary maxima or any maxima is inversely proportional to slit width. Okay, got it? Okay. Now, when we talk about intensity, okay, so basically when you talk about intensity, what is the meaning of intensity? We know that the intensity of central fringe is highest. Yes or no? The intensity of central fringe is highest. Okay, and the formula is given by this, right? Okay. Anyways, if you don't have to remember, it's fine. You just have to know what is the pattern. You don't even have to remember the whole formula. But अगर मान लो कि कभी आ गया, right? Especially for NEET students, then just remember this. Okay, it is 2n divided by 2n plus 1 pi whole square I naught. Okay, the I naught will be the intensity of central maxima, right? Generally ये नहीं आता है, but again CET में या कभी भी अगर आ गया, so this is the formula. Okay, right? Now, according to this, I can observe as n increases, this denominator will also increase and the intensity will decrease, right? So this is the order, right, in which the intensity will decrease. Okay, right? Okay, yes. Okay. Now, what do you mean by resolving power? Tell me, what do you mean by resolving power? Anyone? बताओ. Yes. नहीं तो एक छोटा सा एक्सपेरिमेंट तुम लोगों ने किया होगा ना, like keep your pen and keep it like keep it, yes, right, bring toward your eyes, right, bring toward your eyes. So at some point you will feel that your one pen is like two pens, right? You can see two images, yes or no? Like in. So can I say that, okay, that distance, that is the distance at which I can actually distinguish that I'm having only one image or two image, yes or no? Okay, now, so suppose, right, suppose I'm having two objects, okay, and they're so near to each other, such that because of the diffraction of these two particles, right, right, instead of having, sorry, instead of seeing two objects, if I feel like, okay, it is only one object, right, then that distance is called as, tell me. Yes, okay. So let's try to calculate. So this is the basic minimum angle, right? I can either find minimum angle or minimum distance. So let's see. Okay, let's see how to find it. I hope all of you understood what is resolving power. Okay. So as I said, yes, Manoj, very good, right? So as I said, okay, the minimum distance is given by, right? The minimum distance is given by a formula, which, yes, Manoj is saying as, so it is theta is equal to, okay, it's not r, it's theta is equal to 1.22 into lambda by a, है ना? Right? Got it? Where theta is called as limit of resolution. Theta is called as limit of resolution. But when you talk about resolution, like resolving power, right? Resolving power, which is R, is basically what? It is 1 by theta. Okay, it is 1 by theta. Got it? So it will be A divided by, yes, of telescope. 1 by 2, okay, into lambda. This is of telescope. Okay, resolving power of telescope. Okay. Yes, A is always the, see again, A is slit width, right? So obviously when we talk about lens, right? So it will be the aperture of the object, right? Objective, yes. So see, you just have to, right? See this, it is given, right? When you talk about telescope, okay, or even we talk about microscope, right? This is for telescope, but when you talk about even microscope, I just have to know that resolving power is inversely proportional to lambda. That's it. It's inversely proportional to lambda. Okay. So both microscope as well as telescope. So both microscope as well as telescope. Okay. Yes. Right. For microscope, it is 2 mu sine theta by lambda, and for telescope, it is 1.22 lambda by a, which I have written, right? Which Manoj, you said that is for telescope. Okay. Now let's try to solve simple problem based on that. Very simple problems. Okay. Now wait. Can you see this? Is it very small? Light of wavelength 6,000 angstrom is incident normally on a slit of width 24 into 10 minus 5 centimeter. Okay, find out the angular position of second minimum from central maximum. Tell me. Angular position नहीं ना प्रशांत, एंगल में आएगा ना. See, again you have to understand the basic idea. Okay. Yes हर्षा, फॉर्मूला सही है. Right, easy. Second minimum from the central fringe, right? So what would be the path difference? Tell me. What would be the path difference? 2 lambda, yes or no? Tell me, yes or no? 2 lambda, right? So a sine theta will be equal to 2 lambda. Yes or no? As simple as that. That's it. That's what you have to do. Okay, or directly theta is equal to 2 lambda by a. Simple formula. Theta is equal to 2 lambda by a. You just have to use the formula. Okay, right? So if you use this, you will get sine theta as 1 by 2. Okay, sine theta is 1 by 2. Right? Theta is 30 degree. Yes, Manoj, 30 degree. Got it? Right? Easy. ये सब बोर्ड्स में आएंगे, ऐसे क्वेश्चंस बोर्ड्स में आएंगे. ठीक है. सेकंड क्वेश्चन, light of wavelength, right, 6,328 angstrom is incident normally on a slit of width 0.2 mm. Calculate the angular width of central maxima on the screen, distance 9 meter. So capital D is given, right? Try to solve this, guys. Everyone try to solve this. What is the formula of angular width? Tell me. Angular width का formula क्या है? सबको पता होना चाहिए. अभी देखा हम लोगों ने. एंगुलर सॉमिक एंगुलर, ठीक है, राइट. फॉर्मूला वो लीनियर का हो गया ना, कैपिटल डी से मल्टीप्लाई हो गया तो लीनियर का हो गया ना. प्रशांत, ये विड्थ है, विड्थ में एन नहीं आएगा ना, 2 लैम्डा बाई ए आएगा, राइट. ये सेंट्रल का पूछ रहा है ना, राइट. सेंट्रल पूछा तो सेंट्रल हम लोगों ने कैलकुलेट किया 2 लैम्डा वाला, राइट. हर्षा, कैलकुलेशन एरर हो गया तुम्हारा शायद. You just have to calculate 2 lambda by a. That's it. 2 lambda by a. है ना? So lambda is given. What is lambda? 6.328 nanometer में.
ओके, 0.6328 आ रहा है क्या? कैलकुलेशन आ रहा है क्या कहीं पे? यू आर कैलकुलेटिंग इन रेडियन क्या? हर्षा, प्रशांत, हाँ ठीक है, रेडियन में ठीक है, रेडियन में सही है, रेडियन में दिक्कत नहीं है। हाँ, रेडियन इज करेक्ट, राइट, रेडियन इज करेक्ट, यस, ठीक है, वेरी गुड। नेक्स्ट, try solving this. Next,
Yes, Prashant, very good. Harsha, very good. Right, correct. Easy है कि नहीं? Easy. 20 mm. Very good. Right. So formula putting getting questions आते हैं. Wave optics के ना अगर तुमको अच्छे से समझ में आता है, right? If you actually know the formula and which formula to apply, fringe width, angular fringe width, secondary maxima, right? Secondary minima, then it is actually formula putting getting. ठीक है? So I hope all of you understood, right? One more problem. Try to solve this one. Prashant, you have to calculate what? See ना, तुमको क्या calculate करना है? Right? और n का वैल्यू क्या है? What is the value of n? 3, right? So if you put it, you will get 500 nanometer. Okay. Yes. How many if you're getting 5? Yes, Harsha? Correct, right? है ना? 500 nanometer or 5000 angstrom. Okay, next. Try this. And guys, wave optics का TPP discuss नहीं हुआ है ना? Harsha? Okay. Yes, very good, right? Prashant, Vishnu, tell me. Yes, Vishnu, correct, right? Very good Prashant, ठीक है, इजी है, बन रहा है. हाफ मनोज साइन का वैल्यू हुआ ना, राइट? तुमको क्या निकालना है? एंगुलर वेट थीटा, ध्यान दो, ठीक है, राइट? ओके, वेरी गुड. नेक्स्ट, नेक्स्ट. Tell me guys, light wave of wavelength 600, yes Harsha. Okay, very good. Prashant, Manoj, Somik, Varsha, उदय, दिलीप, त्रिवेणी, ये सब इजी से क्वेश्चंस हैं, तो बोर्ड्स में भी आएंगे. प्रशांत, एक बार कैलकुलेशन चेक कर लो. यस मनोज, बी, ठीक है, सही है. ए, capital D is given, small, this is A, lambda is given, okay, right? Okay, so just formula putting getting, just formula putting getting. Got it? Tell me, got it? Prashant? So first is 4 millimeter and second is 8 millimeter. है ना? This is the formula that we have seen. Okay. So I hope all of you got the idea of using formula, yes or no? Tell me, right? So if I ask you, suppose if I ask you what is the difference, right? What is the difference between interference and diffraction? What will be the difference between interference and diffraction? Tell me. ये boards में question आ सकता है, right? Tell me, point wise. First, when it superposition हिसाब से, when you talk about superposition in case of interference, it is because of one wave or two wave. Tell me. एक तो definition लिख लोगे, right? So हाँ, first is interference, right? Is superposition of two waves coming from two different coherent sources, right? But when you talk about diffraction, it is superposition of two waves coming from two different part of the same wave front, right? The second is in interference pattern, all bright lines are equally bright and equally spaced, means fringe width are same, right? But when you talk about diffraction, the intensity decreases as it moves from central to sides, right? Third, all dark are totally dark. And this all dark are not perfectly dark, right? They're basically with less intensity. Okay. Now, let's see this. Question number, right? This, try solving this. Step by step, guys, try solving this. A slit of width A is illuminated by monochromatic light of wavelength 650 nanometer. Formula putting getting. Okay, first minima, right? Lambda by A. Sin theta is lambda by A, right? Angle is given, हो जाएगा. Very good. Formula putting getting, है ना? सबको आइडिया लग रहा है फॉर्मूले का? Next, see, wave optics is easy for both boards, right, as well as competitive examinations if you understand which formula to use. As simple as that. Okay, next one, try to solve this. Next one. सब कोई एटलीस्ट तुम लोग फॉर्मूला लिख लो. अगर कैलकुलेट भी नहीं कर रहे तो फॉर्मूला लिख लो कि क्या है, क्या यूज होगा. यू शुड नो विच फॉर्मूला टू यूज, राइट? इट्स क्वाइट इजी. नाउ थिंक अबाउट इट ना. अभी हम लोगों ने किया सेम फॉर्मूला यूज हो रहा है. यहाँ पे क्या पूछ रहा है? डिस्टेंस बिटवीन first two dark bands. So what is this? Tell me. Don't you think this is the central bright fringe width? Yes, very good, Harsha. Right? है ना? Distance between first two dark bands, right? First two dark bands. So ये central है. फिर यहाँ पे तो इसके और इसके बीच का distance, so nothing but width of central bright fringe. And what is the formula of 4.68? 4.68 प्रशांत, 4.68. ठीक है. 2 lambda d by a. Very good. है ना? Clear? Tell me, clear? अगर तुमसे पूछता सेकंड, राइट? अगर फर्स्ट ना पूछ के सेकंड पूछ देता तो क्या करते तुम? बताओ. यस, वेरी गुड हर्षा. बिकॉज सी, सेंट्रल का हो गया ना, मुझे पता है कि बाकी उसके बाद वाले का क्या होता है. ये लैम्डा डी बाई डी, है कि नहीं? राइट? उसके बाद टोटल डिस्टेंस पूछा जा रहा है ना, है, फिर डार्क आएगा ना, राइट? तुम ऐसे कैलकुलेट कर सकते हो. यस, क्लियर अंडरस्टैंडिंग होना चाहिए. ओके, solve this. ओके, सो लैम्डा 2. ओके, मनोज, विष्णु, देखो तुम लोग कुछ कैलकुलेशन हो रहा है क्या? सिंपल फॉर्मूला क्या है बताओ? 3/2 ना? यस और नो? राइट? सो कैन आई से दैट लैम्डा 1 by d is equal to 3/2 lambda 2 by d? So 440 होना चाहिए ना, राइट? 440 होना चाहिए. यस और नो? टेल मी. गॉट इट प्रशांत? 440 ना, राइट? 2 into 660 by 3. Okay, so that is the end of diffraction. I hope everyone understood diffraction. सबको समझ में आ गया? प्रॉब्लम्स भी समझ में आ गए कैसे प्रॉब्लम्स बनता है, कैसे अप्रोच करना चाहिए, फॉर्मूलाज एंड ऑल. या मिसिंग है. ठीक है. So next topic is polarization. Talk about this topic, polarization. This is very easy topic, very easy topic. Mostly theory, right? Only two small formulas, right? Two small formulas. One of Bruce triangle and one of, as Harsha said in last class, Malus law, right? Okay, right? Yes, Malus law. Now, when you talk about polarization, I hope everyone know what is polarization. Tell me, anyone have any doubt what is polarization? I hope all of you know what is polarization, right? The definition is clearly evident in the name. When you talk about polarization, it means, right, to polarize a light. What is the meaning of polarize a light? Tell me. What's the meaning of polarizing a light? Vishnu, tell me. पता है, word पता है, but अगर तुमको definition लिखना है, you have to write the definition in your words. What you will write? Think about it. Prashant? Yes, right? So I can say that polarizing, like polarizing, right? Polarizing of light means, okay, yes, restricting the path, restricting the variation of light or restricting the direction in only one direction. Yes or no? As simple as that. Yes or no? Okay, now if we see the light, they are basically in all directions. When you talk about light, right, light is in all direction. Okay, and that is called as unpolarized light, in all directions. Now suppose I want this to pass through, right, in one direction, means either x axis, along x axis or along y axis, right? Okay, in one plane. Now that process is called as polarization. That process is called as polarization. Okay, so what is polarization? So it is basically a phenomena of restricting the vibration or basically light, okay, right, or any wave basically in one direction, okay, in one direction or direction perpendicular to the propagation of wave. Got it? Right? Now it is done by instrument called polarizer. Okay, it is done by the instruments called polarizer, which contains some chemicals, right? If you remember optical astigmatism, that they contains optically active, right? Yes, or Nicole prism. Yes. Okay. So I'm not going to tell you how this works. I hope all of you, yes, Nicole prism, tourmaline crystals, right? Okay, so I hope all of you already know that how those things works. Okay, they just polarize the light, unpolarized light in one direction. Okay, the crystals, you have to remember the name. Okay, you have to remember the name, right? Okay, so see, when you see this, right, when you see this, suppose I'm having on, this is your ordinary light, it is passed through a polarizer. Now this polarizer, right, suppose this polarizer will let the let the light to pass through only in one axis, right? Think about it. So this is your unpolarized light first, right? Unpolarized light. Now this polarizer will let the light to pass only in one direction. Okay. Now suppose we have another polarizer with same orientation, right? Same orientation. What will happen? Again, nothing will happen because it is already polarized. So it will pass through this polarizer with same orientation. But when you turn it or when you rotate it, okay, when you rotate it, then what will happen? Can I say that no light will pass through this? Manoj, tell me yes or no. Depending on angle, Harsha, depending on angle, intensity decreases, right? But if you totally rotate it like 90 degree, then what happens? No light will pass through it, right? Okay, got it? Okay, if it is 90 degree, then no light will pass. If it is less than 90 degree, then the intensity will be low because some part of this light will be passing through this second polarizer. Okay, so this is the theory. This is the theory part. Now, when we talk about, right, how much it will be passing, right, and what is the angle? Okay, so that is given by Brewster angle. That is given by Brewster angle. Okay, and what is Brewster angle? Brewster's law. Now let's see. Suppose we have an unpolarized light. Suppose we have an unpolarized light. Okay, and it is passing through your medium. Okay, either your glass, right? So nickel prism, right? Or yes, U is equal to tan theta. So you might ask to get like to derive this. Okay, 2-3 marks का question आता है, right? Yes, polarization by reflection. Now, if you see this, this is your unpolarized light. Now, at point P, both reflection as well as refraction is taking place. Yes or no? Right? Okay. Now, I can say that some portion of that light, some portion of that unpolarized light will be reflected, and that reflected light is your polarized one, 100% polarized one, and some part of it will be refracted, which will be partially polarized, and the angle between these two should be 90 degree. The angle between these two should be 90 degree, right? Right? And according to law of reflection, reflection, this angle and this angle should be same. Okay, right? So can we use my Snell's law over here and find, right, the refractive index of this material in terms of this theta? Tell me. Right? Yes, very good. Just use Snell's law, na? Just use Snell's law. Okay, right? Very good. So I can say that mu is equal to tan p, theta p, or theta p is equal to tan inverse mu. So this gave me the angle, right? The angle which is required for polarization. Yes or no? Yes, Harsha. Now let's try to find one problem. Okay. Now suppose, just show you one problem. Suppose that angle is critical angle. Suppose that angle, right, is, or yes, yes, Prashant, it depends on refractive index. Now that's what happens here, right? Think about it now, right? यहाँ पे क्या हुआ है? Light is passing through nickel prism, right? Light is passing through nickel. But it depends on the angle also. It depends on the angle also. For example, अगर तुम glass की बात करते हो, ठीक है? This is about other medium only, प्रशांत, ठीक है? ये जो है ना, ये other medium के लिए ही है. This is for the medium like glass or air. This is what you're asking. समझ में आया? Now for this there must be some angle, right? ठीक है? समझ में आ रहा है कि नहीं ये चीज? Because when you talk about your polarizer, Nicole Prism and all, they will polarize, doesn't matter whatever the case, they will polarize. And this is polarization by reflection. Okay, this is polarization by reflection, and it occurs when light travels from, or unpolarized light travels from one medium to other medium, and there is, right, there must be some angle, right, and that angle is your Brewster angle. Got it? समझ में आया प्रशांत? वो नेक्स्ट देखेंगे ना, वो नेक्स्ट देखेंगे, अभी तो बाय रिफ्लेक्शन कर रहे हैं ना. ये सबको समझ में आएगी नहीं, बताओ पहले, ये सबको समझ में आएगी नहीं, राइट? तुमको ये पूरा पॉइंट्स लिखना पड़ेगा डेरिवेशन के लिए. ओके, so this was derivation. Okay, next, as Prashant asked, by refraction. Now, when you talk about normal polarized, okay, think about it, right? Think about it. Now, when we talk about by deflection, okay, we were taking one glass, okay, and by deflection we were getting what, 100% polarized light, but by refraction or refracted light was partially polarized. Yes or no? Tell me, yes or no? Okay, now if we repeat the process multiple times, if we repeat the process multiple times, means instead of just keeping one, right, slide, one glass slab, right, if I keep 20-30 slides, what will happen? So this will partially polarize, then again this will partially polarize, again this will partially polarize, again this will partially polarize, right? So after some time, okay, even the refracted light will be totally polarized. Okay, got it, Prashant? समझ में आया? ठीक है? And reflected light will be polarized, obviously. ठीक है? Okay. Now the next is something called dichroism. Okay, frankly speaking, I don't have any idea about this. Okay, everyone. So let's see question number 1, right? Question 1 theory. I hope all of you can solve easily. Question 1 क्या है? Answer जल्दी बताओ. Question 1 का आंसर क्या है? I'm getting both answers C and D. First is D, na? Right? First is D. Question पढ़ो क्या है? Not explained by, not explained by. ठीक है? Right? Refraction, reflection, diffraction, all are explained by this fusion construction of wavefront, right? हम लोगों ने पढ़ा ना? Origin of spectra is not explained by. Simple. First का D. Second, which of the following phenomena is not common to sound and light wave? Polarization. बाकी सब common है. By the way, last topic तो Doppler effect of light. I hope Doppler effect of light already पता है सबको. ठीक है? Same formula as Doppler effect of waves जो हम लोगों ने पढ़ा है कि नहीं? तो अगर मान लो उससे कभी क्वेश्चन आता है तो कर लोगे ना, सेम फॉर्मूला है, right? Yes, just replace V with C. Okay. Third, interference is possible in yes, both light and sound wave. C, very good. Fourth, Young's double slit experiment is performed with blue and green light wavelength, this and this respectively. If x is the distance of fourth maxima from the central one, then easy, directly proportional होता है ना? Tell me, directly proportional होता है lambda के, x is directly proportional to lambda. Very good, right? So answer is C. Okay, next. Fifth one. In YDS, the fringe width is found to be, okay, fringe width given. If whole apparatus is immersed in water of refractive index 4/3 without disturbing the geometrical arrangement, the new fringe width will be, tell me. I hope all of you remember, right? Yes, beta by mu. Very good. Beta by mu. Yes, Harsha. Right? So the answer is A. The answer is A, na? This divided by 4/3. Right? So it will be 0.3. Got it, Vishnu? Everyone got this? मैंने बताया था ना, optical path length बस change होता है, right? So everything will be divided by beta, na? Tell me. Because lambda dash will be lambda by mu. Yes or no? Tell me. Okay. Next, sixth one. Sixth one. Tell me sixth आंसर क्या होगा? In YDSC, two coherent sources are placed 0.90 okay, it is slit width is given, sorry, 1 meter away, okay, given if it produces second dark fringe at a distance of 1 mm from the central fringe, okay, right? The wavelength of monochromatic light used would be, अब देखो तुमको क्या क्या दिया है, तुमको x दे दिया है, x दे दिया है, कैपिटल D दे दिया है, राइट, स्मॉल d दे दिया है और n भी दे दिया है, लैम्डा पूछ रहा है, निकल जाएगा, टेल मी, निकल जाएगा, फॉर्मूला क्या है? I hope everyone remember x is equal to n lambda capital D by D, n lambda capital D by D, yes or no? Tell me, yes or no? YDSC है ये, इसीलिए. Yeah, sorry, it's 2n plus 1 2n plus 1 by D. 2n plus 1 by D. ठीक है, 2n plus 1 और 2n minus 1 डिपेंडिंग ऑन कि तुम n का वैल्यू क्या लेते हो, ठीक है, राइट, मिनिमम है ना, या माय बैड. नेक्स्ट सेवेंथ. Yes, very good. Seventh is A. Very good. Easy formula putting getting. Next, eighth. In YDSC, right? Light wavelength given, distance given, distance screen capital D given, central maximum is x equal to 0. Third maxima, again, formula putting getting. Right? तो यहाँ पे तुम्हारा n lambda d by d हो जाएगा, यहाँ पे मैक्सिमम है ना, तो यहाँ पे n lambda d by d हो जाएगा, n lambda d by d, और n is equal to 3 हो जाएगा, ठीक है. Next, yes, 8b. Now 9th is a theory. If yellow light emitted by sodium lamping in YDSC experiment is replaced by monochromatic blue light of the same intensity, okay, what will happen? Tell me. Fringe width increases, fringe width will decrease, fringe width will remain changed, fringe will become less intense. Tell me, blue light का वेवलेंथ ज्यादा होता है कि येलो लाइट का? बताओ, पहले ये सोचो, ब्लू लाइट ज्यादा होता है कि येलो लाइट का? राइट, तो अगर ब्लू चेंज हो गया तो क्या हो जाएगा? डिक्रीज कर जाएगा ना, तो आंसर इज ए ना, यस और नो, राइट? गॉट इट प्रशांत? समझ में आ गया? Now, 10th one. Interference was observed in interference chamber where air was present. Now the chamber is evacuated, and if the same light is used, a careful observation will see. Tell me. ना एक चीज बताओ, ठीक है, एक चीज बताओ, what is the formula of lambda? What is the formula of lambda? Now in medium, can I say that lambda dash equal to lambda by mu? Lambda dash is equal to lambda by mu in medium? Yes or no? Right? Yes or no? So air में mu we assume that it's comparatively equal to 1, but it's actually not equal to 1. It is slightly more than 1. Yes or no? Think about it. Logic. Yes? Now, if it is removed, then what will happen to lambda? Lambda will increase or decrease? Increase. Now, if lambda will increase, then what will happen to fringe? What will happen to fringe weight? Increase. So the answer is D. Got it? See, ये थोड़ा अच्छा conceptual question था, right? Easy but conceptual, right? Okay. अगेन स्कैटरिंग को हम लोग इग्नोर करेंगे हर्षा यहाँ पे, ठीक है, मतलब वो फिनोमेना ही अलग है ना, स्कैटरिंग तो अलग ही फिनोमेना है, उसको तो इग्नोर ही कर रहे हैं हम लोग, यहाँ पे सिर्फ इंटरफेरेंस देख रहे हैं, ठीक है, and it's not the air which scatter light, it's the dust particle in the air which scatter light. Yes or no? ठीक है, नेक्स्ट 11 to 15 एक बार जल्दी देखो, 11 to 15. Okay, 11th, right? 11th. A parallel beam of monochromatic light of wavelength 5000 angstrom is incident normally on single narrow slit of width given. Wavelength given, width given. Light is focused by convex lens on a screen placed in focal plane. Okay, right? The first minimum will be formed. The angle of diffraction is equal to. Now, ध्यान दो, ये बेसिक फॉर्मूला है, वेरी इजी फॉर्मूला, हम लोगों ने बहुत क्वेश्चन ऐसा किया है, ठीक है, राइट? सो थीटा पूछा है ना, सॉरी, थीटा पूछ रहा है, वो भी किसका? फर्स्ट मिनिमा का। फॉर्मूला क्या है? थीटा इज इक्वल टू व्हाट? लैम्डा बाय ए। इजी है, इजी है, yes, the answer is C. Very good, right? Very good, C. Next, second, a Fresnel biprism experiment, two position, right? So देखो यही आ गया ना, वो यहाँ पे आ गया नीट में, right? Two position of lenses are given separation between slits 16 and 19 centimeter. What is the actual distance of separation? So actual distance separation root r1 r2 होता है, ठीक है, root r1 r2. नीट वालों सबको ही लिख लो बस। नोट्स में जो मैं जो शेयर करूंगा उसमें ये लिखा हुआ था, ठीक है, राइट? उसमें ये लिखा हुआ है, मैंने बोला एक बार बस देख लेना, ठीक है, क्योंकि नीट में या सीईटी में आ जाता है, राइट? तो बस ये फॉर्मूला है, हो जाएगा। नेक्स्ट 13th, color appears on a thin soap film फ्रेस्नेल बाइप्रिज्म की बात कर रही है, बात हो रही है, ठीक है, फ्रेस्नेल बाइप्रिज्म होता है ना, राइट? दैट्स व्हाई द नेम फ्रेस्नेल बाइप्रिज्म। ओके हर्षा, एक बार फिर से एक बार देख लेना, ठीक है, मैं भेज दूंगा, राइट? नाउ सेकंड 12th one, yes, a Fresnel biprism experiment. Okay, 13th बताओ। Yes, 13th, C. Color appears on soap film and on soap bubble due to the phenomena of C na, C, Manoj, C, right? Due to interference. Okay, right? Due to interference. Next, 14th. Which of the following shows particle nature of light? Easy, right? बच्चे वाला photoelectric effect, D. ठीक है? Now 15th one. 15th. A paper with 2 marks having separation D is held normal to line of sight of an observer at distance 50 meter. So capital D is given. The diameter of eye lens of observer is 2 millimeter. So diameter of eye lens is given 2 millimeter. Which yes 15 try करो सबको अच्छा क्वेश्चन है. अच्छा क्वेश्चन 15 ठीक है. Which of the following is the least value of D so that the mark can be seen as separate? So ये किस पे based हो गया? Theta should be same, yes or no? Tell me. Resolution of I पे हो गया and resolution of I मतलब simply क्या theta is equal to lambda by D लेंगे हम लोग, right? Resolution of I is this, yes or no? Right? And for an object, this is equal to what? This is the distance by capital D, yes or no? The distance between the two objects by capital D. The distance of object from the eye, yes or no? Tell me, yes or no? Right? Prashant, Harsha, Manoj. You asked to find what? X. Can you find X? Equate them. You can find X, which is lambda D by D. Okay? Right? So the answer would be 15 answer. Yes, very good. B. B होगा मनोज सही. हर्षा कैलकुलेट करो. B होगा 12.5 सेंटीमीटर. ओके. यस प्रशांत B. Now 16th formula putting getting 16th I hope सबको पता होगा. 16th tell me. Calculate. D. Very good, right? Because प्लस माइनस वाला कैंसिल हो जाएगा तो ये बचेगा. D. 16th D. Very good, right? 17th just go through the question. 17th a lens having focal length f and aperture of diameter D, right? पढ़ लो एक बार सब कोई. 17 पढ़ लिया. Okay, let's see the options. So a lens having focal length given, aperture diameter given, right? Intensity given, aperture diameter divided in central region of the lens is covered by black paper. Okay. Focal length of the lens and intensity will be respectively. Now ये बहुत ही अच्छा क्वेश्चन है, राइट? हम लोगों ने शायद या तुम लोगों ने ऑलरेडी किया होगा. लेंस के नीचे वाले को क्या कर दिया गया है? कवर कर दिया गया है, राइट? अपर्चर कवर कर दिया गया है ना. अपर्चर कवर करने से फोकल लेंथ में चेंज आता है क्या? टेल मी, थिंक अबाउट इट. अपर्चर कवर करने से फोकल लेंथ में चेंज आता है कि नहीं आता है? नो, इट विल बी सेम, बट इंटेंसिटी में चेंज आ जाता है. यस और नो? इंटेंसिटी में चेंज आ जाएगा, राइट? बिकॉज यस, और इंटेंसिटी कितना हो जाएगा? इंटेंसिटी कितने से रिड्यूस करेगा? बताओ, इंटेंसिटी कितने से रिड्यूस करेगा? यस I/4, तो बचा हुआ इंटेंसिटी कितना होगा? थ्री I/4. So answer is very good. The answer is C. ठीक है? Easy, right? Very good. Now 18th one. Eighteenth, a YDSC slit, right? Slits are 2 mm apart, right? Lambda 1, lambda 2 given. At what minimum distance from the common central bright fringe on the screen 2 mm distance, capital D is given, will the bright fringe of one interference pattern coincide with the bright fringe of the other? Tell me. X should be same, na? Tell me, X should be same, yes or no? Right? So can I say that x1 is equal to n1 lambda 1 d by d, right? And x2 is equal to n2 lambda 2 d by d. And this x1 should be equal to x2 for coinciding. So n1 lambda 1 is equal to n2 lambda 2, yes or no? Yes or no? Right? So हम लोग assume करेंगे consecutive है, हम लोग assume करेंगे consecutive है, एक को n मान लेंगे, एक को n+1 मान लेंगे, right? Then we can get the value of this and we will solve. Okay, right? Wait everyone, someone came. Wait. हाँ, see again Manoj, right? We cannot find n1 n2. So जब भी ऐसा क्वेश्चन आता है ना, हम लोग मान लेते हैं वो consecutive है, एक को n मानते हैं, एक को n+1 मानते हैं. ठीक है? कुछ तो मानना पड़ेगा ना, right? Okay, next. Yes, yes Prashant, correct. 18th का A. 18th A. 19th second. 19th, a parallel beam of fast moving electron is incident normally on a narrow slit. A fluorescent screen is placed at a large distance from the slit. If the speed of electron is increased, which of the following statement is correct? Speed of slit is increased. Sorry, speed of electron is increased. What will happen? Think about it. Speed increase, frequency is same. What will happen to wavelength? Decrease. Makes sense, na? Right? Frequency will decrease. If frequency will decrease, what will happen to angular width? What will happen to angular width? Decrease. What is the answer? हाँ ना, wavelength decrease करेगा ना? अरे lambda is equal to h mu ना? Lambda is equal to h by mv. Yes or no? De Broglie's wavelength. Frequency will be constant na? That's what I said. ओके, मिस्टेक से शायद बोल दिए होंगे, गलती से बोल देंगे. फ्रीक्वेंसी इज कांस्टेंट, हाइट वेवलेंथ विल डिक्रीज. ठीक है, राइट, ओके। 20 इजी, 20 बताओ, 20 बहुत इजी सवाल। लास्ट टू प्रॉब्लम्स, देन विल जस्ट सी जेई वाला। यस, वेरी गुड, 20 इज सी। 4 टाइम्स ना, कैपिटल डी और स्मॉल डी को चेंज कर दोगे तो 4 टाइम्स आ जाएगा, राइट। 21, 21 easy, 21 is also easy. At the second minimum of diffraction pattern, the phase difference between the ray coming from two edges slit is, think about it, second maxima मतलब क्या होता है, 2 lambda, right, 2 lambda, yes or no? So phase difference will be what, 2n pi, और n is equal to 2, यहाँ पे 2 है, 4 pi, yes, very good, right, easy, got it everyone, basics, I hope basics clear हो गया होगा, ठीक है। Okay, just give me 1 minute. सेवनटीन्थ नॉट क्लियर, कौन था, क्वेश्चन क्या था 17th, हर्षा क्वेश्चन क्या था, याद है? वेट, ओके सी, देखो जब भी अपर्चर को शेड किया जा रहा है ना, जब भी अपर्चर को शेड किया जाता है, राइट, फोकल लेंथ विल नॉट चेंज, फोकल लेंथ विल बी सेम, फोकल लेंथ सेम रहने वाला होता है, ठीक है। बट व्हाट डू यू थिंक अबाउट द एम्पलीट्यूड, टेल मी व्हाट अबाउट द एम्पलीट्यूड, बताओ ना क्या होगा। पहले ही ऐसे आ रहा था मान लो, राइट, ओके, ये पूरा ऐसे आ रहा होगा, so amplitude will decrease to half, yes or no, the amplitude will decrease to half, yes or no? Now if amplitude is decreased to half, right, what will happen to intensity, right, intensity कितना decrease करेगा, 1/4 intensity decrease कर जाएगा, intensity 1/4 decrease कर जाएगा, right, so अगर intensity 1/4 decrease कर गया है, remaining intensity कितनी हो जाएगी, I minus I/4 which is 3I/4, got it Harsha? Okay, next, I don't know what happened, wait, I have to just close this, both ray optics and wave optics, okay, so हम लोग जल्दी पहले, wait, I'll just see how many problems we have here, ठीक है, lots and lots of problems, we'll just do wave optics first, okay, we'll just do wave optics, ray optics क्वेश्चन हम लोग बाद में करेंगे। हाँ हर्षा, राइट, वे ऑप्टिक्स कहीं अभी करते हैं पहले, ठीक है, रे ऑप्टिक्स डिवीजन की बात करेंगे। सो 1 to 5 में वे ऑप्टिक्स का क्वेश्चन कौन सा है, फोर्थ, राइट? फोर्थ, टेल मी। ऐसे 1 to 5 सब इजी है, फोर्थ एक बार देखो जल्दी से, मैं बता रहा हूँ वो बस देखो। फोर्थ इजी है, हो जाएगा। व्हाट्स द आंसर? फोर्थ एवरीवन, फोर्थ। Yes, D, right? Basic ratio, inversely proportional. I have told you, right? Prashant, it's inversely proportional. Resolving power R is equal to 1 by